Welcome to my discussion for this week. In my discussion, I will be covering measures of center, variance, and standard deviation. The first thing we'll cover is the three measures of center that were presented by Stephanie Mullen in her 2021 book, Hands-on Data Analysis with Pandas, 2nd edition, a Python data science handbook for data collection, wrangling, and analysis, and visualization. In statistics, the mean, median, and mode are all three measures of center of data distribution that we'll be covering today. According to Mullen, these three measures all have their own strengths and weaknesses, so consideration should be made before you choose one over the other, and having a better understanding of each one will help inform your decisions. Mullen noted that there are two types of mean, the population mean and the sample mean. The population means are, quote, denoted by mu, while the sample means are, quote, denoted by x bar. Both of these means are calculated by, quote, summing all the values and dividing by the count of values, and they are all measures of the center of the data sets. According to Josh Starmer's 2019 video, Calculating the Mean, Variance, and Standard Deviation, clearly explained, the difference between the sample mean and the population is whether or not the average represents the average of a subset of the data, or a sample of the population, or whether this average represents the average of the entire population. Mullen pointed out that there is one thing to be wary of when using the mean as a measure of center, and that is, since the average is, quote, very sensitive to outliers, we likely don't want to use this measure of center when outliers are present in our data, since they will largely skew the curves. Instead, Mullen recommends using the median when you have outliers in your data. So what is the median? According to Mullen, the median is the 50th percentile of the data being investigated. This median is a measure of center similar to the mean or the mode, which we will discuss later, and this one is robust against outliers, meaning it is not affected by them quite as much as the mean is. For example, we have this example data of 10, 15, and 100. 15 is the median in this example because half of the values, the top half being 100, is greater than 15, while the bottom half of the values, being 10, are less than 15. The final method of center distribution we'll be looking at today is mode. The mode, according to Mullen, is the most common value in the data set that we have. For example, if we have the data red, blue, green, and red is the mode since it occurs twice, whereas the other two values only occur once. The mode is best used when you have categorical data rather than qualitative data, according to Mullen. The next thing we'll cover is variance and standard deviation. Now that we have a basic understanding of measures of center, we're going to look at two ways to measure how far data is from that center. The first way we can do this, according to Mullen, is by using variance. Variance is the average squared difference of values from the population mean. However, we can also calculate the sample mean using a similar but different method. To do that, we must use a slightly different formula, which instead of dividing by the total number of values, we divide by the total number of values minus 1. According to Mullen, this is called Bessel's correction, and this will give us the squared units when we've calculated variance, which isn't typically that useful for calculation, other than for use in calculating standard deviation. According to Mullen, standard deviation is a little different from variance in that it is a measure of the average spread of our values from the center. Standard deviation is calculated by just taking the square root of variance, and this will convert the square units back into regular units which can then be used to get a better understanding of how spread out our data is in our data set. Thank you for listening to my discussion. That will be all.